Hi everyone, here are your notes for section 6.4. So now what we're going to be getting into is different ways to prove that triangles are similar. If you guys remember back in chapter 4, we proved triangles congruent with side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. So now we're going to get into the shortcuts that we needed in order to determine whether triangles are similar or not. So if you guys remember back in section 6.3, if we had a triangle, we had two questions we had to ask. The first question was, do you have congruent angles? If you did, then we checked it off. And then the second question was, are your sides proportional? Right? And then we would make up ratios of all of our sides. So 2 over 4, does that equal 2 over 4? Does that equal 2 over 4? Yes. And if that was the case, then we knew that we had similar triangles. Well, there are shortcuts that we're going to go through here in section 6.4 that we don't need to do all of that to determine whether we have triangles. And this only works with triangles similar to each other. So our first shortcut that we have is what's called AA similarity. So angle, angle. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are going to be similar. So if you can come up with, let's say I have triangle ABC and triangle DEF. If A is congruent to D and B is congruent to E, then we have enough information to say that they are similar. So we could say triangle ABC is similar to triangle DEF by angle, angle similarity. So there's my similarity statement and there's my justification. So that's pretty easy. So if you're given two angles and they're congruent, then we know that we have similar triangles. The second one is side, side, side. We've seen this one before, but now with our side, 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 we're not looking for congruency. What we're looking for is whether my sides are proportional. So it's a little bit trickier. So I'm going to go ahead and label my triangles down here, D, E, F. So it says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if it's true that AB over, I'm going to go DE, is equal to BC over EF, which is equal to, what's my last side I'm missing, AC over DF. So if all those ratios are the same, then we know that triangle ABC is similar to triangle DEF by side, side, side similarity. Okay, and then the third one we have is side, angle, side, which we've seen before, but again, we're dealing with proportional sides and not congruent sides. So if an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides including these angles are proportional, then the triangles are going to be similar. So if I have triangle ABC, DEF, and let's say A is congruent to D. So if we were given angle A is congruent to angle D, and then the sides proportional to it would have to be the ones including it. So you see how AB and AC include that angle, and then ED and DF include that angle. So AB would be proportional with DE, would need to be equal to AC corresponding to DF. So if you have all of that, then we would have them similar. So triangle ABC is similar to triangle DEF, F by side, angle, side similarity. Sorry for my chicken scratch. Okay, so let's go ahead and work through these examples. So example number 1. Notice I have nothing inside of my angles. There's no degrees inside my angles. There's no arcs. So again, our options are side, 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 angle, side, or angle, angle. Notice 2 of them have angles included. Well, I don't have any angles. So that leaves me with only side, side, side as an option. So what do we need to do to check for side, side, side? We need to check all of my ratios and see if they're equal. So I'm going to take my smallest side on the left and compare it to my smallest side on the right. So 21 over 15. I'm going to get my calculator out. 21 divided by 15 is 1.4. And I'm going to go middle to middle. So my middle is 35 and 25. And I'm going to get my calculator out. I'm going to do 35 divided by 25 and I get 1.4. So far looking good. Then largest compared with largest, 42 and 30. So 42 divided by 30 is 1.4. So they are all equal to each other. So I would say, yes, they are similar. It wants me to write a similarity statement. So I'm going to say triangle, I don't know, PQR. Order doesn't matter there, but order does matter here. It's going to be similar to triangle P matches up with X, Q with Y, R with Z, and then my justification is because of side, side, side similarity. So then state the reason why, side, side, side. Number 2, again, our 3 options are side, 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 or angle, angle. Notice I have no sides listed anywhere. So it can't be the first 2, which makes me have to look for angle, angle. So here I have one set of congruent angles, right? Where's my second? Well, 26 and 64 do not match up. But I can find K by doing 180 minus 90 minus 64, which is 26 degrees. And 26 does match up with this 26. So I do have 2 sets of congruent angles. The thirds technically would then also match up with each other, but I don't need that. So I'm done. So yes, they are similar. I'm going to go triangle CDE would be similar to triangle C was the 26, K was on the 26 on the other side, D was the right angle, G is the right angle, and then we're left with H by angle, angle similarity. Okay, number 3, again, no sides listed anywhere on there, so I can't be side, 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 it can't be side, angle, side, so now I'm down to angle, angle. Does everybody see the 2 overlapping triangles? There's this triangle right here. I'll go purple on the other one, and then there's the big one on the outside. So if I recreate those 2 triangles, so purple is PAE, and we're given that this angle is 65 degrees. And then the blue one is right here, which is TCE, 65 degrees. So we've got T and A the same. Or sorry, T and P the same, but I don't have anything else. But notice both of them have an E up top, and E is the same as E. So that's the reflexive property. So I do have 2 sets of congruent angles because they both share that E in common. So yes, they are similar. Triangle PEA is similar to triangle P matches up with T. I'm going to run on my face here in a second. E matches up with E, and then C by angle, angle similarity. All right, 2 more. So here we do have sides. How many sets of sides do I have? I have 1 and 2. I don't have the third, so it can't be side, side, side. Can't be angle, angle. So my only other option is side, angle, side. Do you have an angle congruent to an angle? Yes, you have your 47 and your 47. So now I got to check my sides. So 21 is the smallest on the left. Compare it to the smallest on the right, which is 35. 21 divided by 35 on my calculator is 0.6. Then do largest and largest. 30 over 50, that's 0.6. So they are equal. So I do have a side, included angle, and a side. So yes, triangle XYZ is similar to triangle X matches up with G. Y would match up with D, and then J by side, angle, side similarity. And then the last one I have no side lengths listed anywhere. So I'm looking for angle, angle again, because it can't be any of the other ones, right? So here I have an angle, here I have an angle. Where's my second angle? In the middle with your vertical angles at B. So yes, triangle, I'm going to go ABE is similar to triangle A matches up with C, B with itself, and then D by angle, angle similarity would be my final answer. Okay, that concludes your notes. Bye everyone.